Okay guys, so here if you see, we are learning the working in detail, which we have already learned the working itself in the previous video itself. But if you want to say how you can write in the exam the working of UIT, you can write it like this. First, we have no one thing that we have to discuss is that there is a database, and from the database the data that you have to transmit should come to the URT1, right? That is the first device. So the data is coming from the database to the UART. So the UART that is going to transmit data, that is this UART1 is going to transmit the data. It will receive the data from the database, that is to the from this database it will receive the data that it has to transmit. So this database is used to send data to the UART by another device, like this database is used to send this data to the UART, right? That by another device like CPU, memory or microcontroller. This data is coming, and that from the database it will go to this UART1, and the data is transferred from the database to this transmitting UART in parallel form. You can see bit 0, bit 1, bit 2, bit 3, bit 4, bit 5, bit 6, bit 7. In parallel form, the data is basically transferred from this database to the UART1. This is the first step. Database, from the database the data is transferred parallelly to the UART1, which is then going to transmit to the UART2, right? So now UART1 would create what? Packets. It receives this parallel data from the database. Now it will create a packet. This packet, we know it contains a start bit, the data bit, like 5 to 9 data bits would be the and also then there will be a parity bit that can be 0 or 1, right? Parity bit would be the optional parity bit, and also optional 1 or 2 stop bits are there. Fine. So parity bits can be 0 or 1. That is what parity bit means. Now stop bits, 1 to 2 stop bits are also there, 0 to 1 parity bits are also there. So this either 0 to 1 means parity bits are optional, either no parity bit or 1 parity bit would be there. That's why. And stop bits can be 1 to 2 stop bits would also be there. This is the packet. Now it would create this packet in the next step. Now we have created the packet. Now there is a start bit. Now the start bit, what it do? It will tell the device that okay, the data is going to come there. It will create that wire. I told you it will make that wire was initially high. It will put that low because the start bit is always 0. Now receiver reads that start bit and understood that the data is coming. So it will start reading the data which is there in the data frame. Data frame means this data which is present here. This data is the data, this data that is here, this is the data frame. So it will start to read the data which is there in the start data frame, the UART2, that is the receiver bit. The data frame contains the actual data that is up to 5 to 8 bit long, that would be, and this UART2 would start from the receiving side. It will start reading that data bits. Now there is a parity bit. Parity bit is used for checking if there is any our data and all become correct, if the same correct data has been reached there. If the because sometimes because of electromagnetic radiation or bound rate get mixed matched, or if it is because it is traveling a very long distance, data, there is a chance that the data may change. Okay, so parity bit can be 0 or 1. If parity bit is 0 means total even number of ones there in the bit, that is even parity. Now parity bit is 1 means it is odd parity, total odd number of ones were there. By checking this condition, the UART would know whether it has received the correct or if there is any error in the data it received, or if you got the correct data that was sent by the transmitter side. Okay, so the parity bit 0 means even parity, the number of 1 was even. Now parity bit 1 means it is odd parity, that is the number of ones were odd in the initial data frame. So using this parity bit, it will check whether we got the correct data or not. Fine. And the next thing is the stop bit. The stop bit, what it will do? It will that okay, this is the end of the data frame, that is understood by the stop bit. The sending UART drives the data transmission line, that there is a data transmission wire or line, to what? High. So it was a low voltage, it will set that to a high voltage, that is set 1 bit, right? So we told you first we have the start bit would set this transmission Start bit would trace this transmission line from high to low, it will set. Stop bit would, what it will do, from this transmission line it will set this transmission line from low to high voltage. This also we have discussed in the previous video itself. Fine. Then finally you got the data here, right, in the receiver side, UART. Now UART1 transmitter, that is this TX pin, send this packet serially to this UART2's RX pin. The receiving UART would read the data packet bit by bit, that is because it is serially TX is sending this to RX. So that means serial transmission means the data is read bit by bit. That means bit by bit the data is basically read. Now here if you see, the receiving UART then converts the data back into the parallel form and removes the start bit, parity bit and stop bit. From that data it will remove the start bit, the parity bit and stop bit, and it will convert into the parallel form. That means it now transfers this data packet parallelly to the data bus it has to transfer. So it has to convert it into UART2 would convert it into the parallel bits, and it has to take only what was there in the data from the other parity bit, start bit and stop bit it will remove, and then it will transfer it to our data bus, right? Now we have to understand the other part here, that is the advantages and disadvantages of our UART. That is, advantages is that here only in our serial peripheral interface SPI we have used 3 wires, but here you need only 2 wires. No clock signal is needed. It has a parity bit to check if there is error and all. Now the structure of data packet can be changed as long both sides are set up for it. Now the data packet structure, that is the structure, can be changed whenever we want it. It is well documented and widely used method. So there is a parity bit check to error, 2 wires are only there. Then you can change this data structure, data packet structure also, and also it is something which is most widely used method. There is no clock signal needed. The disadvantage is that the size of the data frame is limited, maximum 9 bits, that is I told you 5 to 8 bits, maximum 9 bits are there, and doesn't support multiple master systems, multiple slave or master systems. Okay, multiple devices, multiple slave or master system, multiple master system it does not support. So the main disadvantages is that our data frame size is limited and it doesn't support the multiple slave or multiple master systems, right? Multiple slave, we have know what do we mean by in S3 itself we have learned the multiple slave system, master system, and also it doesn't support this multiple slave or multiple master systems. That we have to understand. These are the disadvantages. So in this way UART is completed. Now we have only very small topic in module 4 to discuss. Thank you.